A box contains 2 defective Christmas tree lights that have been inadvertently mixed with 8 non-defective lights. If the lights are selected one at a time without replacement and tested until both defective lights are found, what is the probability that both defective lights will be found after 3 trials? What gets challenging about this is because of the circumstances that you're asked to do this, and knowing some logic about how you would go about doing such a test the way they're describing. Because a lot of students would try to go back to some of those combination methods and find out that it really doesn't produce the answer that we're looking for here. Because the combination method, basically, the best I could possibly do is say, okay, well, I'm only going to pick 3, and I want to see the probability of me getting both defects and one non-defect. Well, the thing is, if I pick the 2 defects at first, I'm not going to pick a third one. That would be silly. But this one here is saying that, what's the probability that it's found after the 3 trials are done, after I've tested 3 bulbs, basically. So basically, for that one there, I have to assume that I didn't get a situation where, I picked the 2 defects on the first 2 picks, because it would be pointless to pick any others after that. After I found my 2 defects, I know that at that point I found them all. So I have to look for 2 very specific instances where I have 2 defects and 1 non-defect out of 3. So when I look for the probability that both defects are found after the 3rd pick, which is what I'm looking for here, I have to assume that, well, I'm looking for the probability of me picking a defect on the first time I pick, a not defective light, and then a defective light to get my 3rd one. I have to assume that the 3rd one chosen is defective. But I've also found the other defective one in one of the first 2 trials. And then along with that, the other possibility is for me to have picked a non-defective light the first time, and then picked a defective light the 2nd and 3rd time. So these are the 2 circumstances I have that, would combine together would give me the overall probability of me picking both of the defective lights out of this mixture of 10 lights, by the 3rd pick. So when I figure out these probabilities, now I'm going to get a lot of the same numbers in the numerator and numbers in the denominator, just associated with different mixtures of them. But as I look here, well, me getting a defective, probably me picking a defective light of the first pick would be 2 tenths. Then the probability of me picking a not defective light would be 8 out of 9. And then the probability that the 3rd one is defective would be 1 out of 8. And then coupled with that, the probability of me picking a non-defective light on the first pick is 8 out of 10. The probability of me picking a defective light on the 2nd pick, given I've already picked the first one, I did my first pick, would be 2 out of 9. And of course, the probability of me getting a defective light on the 3rd pick would be 1 out of 8. So I would basically add these 2 together. I would do some simplification first. And I would basically get 1 out of 45 plus 1 out of 45, which is 2 out of 45, which is 0.0 repeating 4s. So about 4.44% chance of this occurring under the description given.